Hey everybody, Mr. Fortin here with your fourth notes of the year. Now we're going to talk about describing graphs. Now we're focused in chapter one at families of functions and the different way that patterns grow and change in the world around us, and how we use math to sort of describe that growth. Very important topic in Algebra 1, so that's why we spend this time here in chapter 1, really looking at functions and describing the differences in them. And the graph is a good way to describe the difference in them, what the heck's going on, okay? So write down the notes as I'm talking here. It's just kind of good because you could just listen, you could just read it real quick, but then you might not question. So I would just write this down just so you feel a little more connection to it. Knowing how to describe a graph will allow us to understand the graph better and let us understand the function and how it changes. When describing a graph, remember the acronym M.I.S.S.R. That's the acronym I'm going to use in class, okay? So I know that in the first few sections, you're looking at different types of functions and trying to really figure out, get to the bottom of how they're different from one another. And it can be kind of an overwhelming feeling being, hey, describe this graph completely, or use what we've talked about so far to describe it. So what a student in the past has sort of come up with is this acronym to sort of remind us of pretty much everything we've decided is important to say about these functions here. And that is when you are looking at a graph and you're asked to describe a graph. In the book, it'll say describe completely. When it says to describe completely in the book, as it does down here, here's what you need to talk about. You need to talk about M.I.S.S.R. What does the M stand for? Well, we need to talk about minimum or maximum points that are on your graphs here. And as we can see here, looks like we have a minimum. I don't know if we have a maximum. We'll talk about that later. We would talk about, does our function increase or does it decrease? And we're talking about our y values there. As we move on our graphs from left to right, because again, we read our graphs from left to right, just as if we're reading a book, we read math the same way oftentimes. Is the output increasing or is it decreasing? Because we want to talk about, well, increasing, decreasing. That's a big difference from one another. Okay, the shape. Is there any particular thing that we can compare the shape of our graph to? Like, does it look like anything else from our lives? So we can remember, oh, that shape, okay, it's gonna be part of that family of functions, behave this way. Okay, so shape here. So M.I.S.S.R. Okay, so you have to remember MI, minimum or maximum points. I for increasing or decreasing. Don't forget about decreasing here. What does the first S stand for? It stands for shape. Okay, our shape here is going to look like that. I've shown that to you in video number 2. We had a graph that looked kind of like this. S for symmetry. Okay, symmetry here. If I fold it in half somewhere, is it going to be on top of one another? Is it going to be symmetrical? Okay, is it going to be symmetrical? My head is pretty symmetrical, right? Check out Mr. Fortin's head. If I draw a line down here, well, my ear would be on top of my ear, and my nose would get cut in half, would be on top. If I fold it together, my eyes or our heads are pretty symmetrical. Is this graph symmetrical? We'll talk about that later. So you have to talk about symmetry. You have to talk about special points. Okay, what are special points, guys? Special points are intercepts. So x-intercept, okay, y-intercept, or x-intercept, sometimes we have 2. Y-intercept. What else? Vertex, okay? Vertex is your highest or your lowest point, okay? Highest or your lowest point here. M stands for minimum maximum points. That uses minimum maximum output. Minimum maximum output. Where's this graph? Where's the y value the highest? If we're tracking number of sick people, which we are actually in this one here, what's our highest here? Number of sick people, okay? Vertex might be the highest point, highest point in general, okay? Vertex, those are special points. Those are the main special points, okay? Symmetry, sometimes there's a line of symmetry too, so you got to talk about that. Finally, okay, so M.I.S.S.R, okay, for now, M.I.S.S.R, what's R? For now, R is going to be restrictions, okay? Restrictions for inputs and outputs, okay? Because not every function acts the same as another function, okay? Some functions, we put something in for x, we put something in for the input, it might spit out, a whole bunch of different things for y, right? If we put in a whole bunch of x's, we get a whole bunch of different things for y. Other functions, as we see down here, not all my y values, if this is my x-axis here, this is my y-axis here, not all y values are relevant in this one, okay? The y values are all positive. So anyways, restrictions means what can x, restrictions for inputs, okay, right? What can x and y be? That's the idea. What can x and y be? Okay, so remember, inputs are x, outputs are y, or f of x, right? Or y. What are they, right? Are they all positive? Are they all odd numbers? Are they all negative? Do they start at 3 and above? Like what's going on there? Like, let's describe it, okay? So what I have here, describe the graph below completely. I have a graph down here. One thing, quick plug, and I might link to this video as well. During distance learning, here, there's wonderful Algebra 1 teachers. We actually filmed a video, 10-minute video, just talking about this graph, and we just describe it. Like, what do you notice here? What do you see here? I'd watch that video. It's pretty neat. You get to see some of your other teachers you might have a little bit in the future. There's Mr. Fortin, Mr. Cheng, Mr. Knight, Mr. Chan. We go through this whole video here. But what I'm going through for notes is I want to go through M.I.S.S.R right now. I want to go through M.I.S.S.R right now for what I just told you, what I look for at least, that you're describing this completely, okay? You can go off this list, M.I.S.S.R, okay? So what do we have here? If I have to describe the graph below completely, I'm going to talk about M.I.S.S.R. I might even just write it out so that I don't forget to talk about something. Okay, here's what we do. We have to describe this graph below completely. Start with M. What's M mean again? Minimum or maximum points. Describing graphs. Okay, so this graph has to do with COVID death, okay, back in 2019, COVID-19. This is our dates back in 2019. Remember, we started February 2019. February 23rd or so. Ooh, gosh, school closed. When did school close? March? Was it April? I think it was April, actually. Okay, so anyways, looks like this here, minimum points is about down here. That's, looks like we're actually a little bit above zero. Looks like we had some COVID deaths back in February. Not many, right? Not many in February 2020, right? This is 2020 data here. Okay, so this looks like this point here. It doesn't look like it's quite the origin. It looks like it's maybe, I don't know, 20 above the origin. So minimum of COVID deaths, really. Minimum point at 0.20. So minimum output, right? Minimum of daily deaths. It's kind of morbid here. Minimum output of 20 COVID deaths. That's the fewest. And we're looking at our graph here as far back as our data went to. We've had at least 20 COVID deaths in a day, right? Than in our world. Of course, that got larger and larger and larger for a while. Okay, minimum point of 0.20. So minimum output of 20 COVID deaths on any given day as far as our data goes back to. Okay, I, increasing, decreasing. Well, for our data here, February of 2020 to the end of March 2020, COVID was taking off, huh? It wasn't doing it, it was increasing, okay? So here I got increasing. That's what I want to say here for my I. I'm going to write increasing, okay? M, minimum point, I did that here. I, increasing, I'm done. I'm pretty much done here. Y is increasing, okay? So remember, we read math from left to right, from left to right. So here's how you can figure out whether it's increasing or decreasing. You always start on the left of the graph, okay? Start on the left of the graph. Put your finger on top of it, then trace, okay? And then figure out, is my finger going to go up or is it going to go down? It's going up here, okay? It's definitely going up here, okay? So this is increasing, and we might want to say something about speed. Am I increasing very fast here? Well, not really. I'm increasing a lot faster over here. So you might want to word that out a little bit here. I'm going to increasing, and I'm going to increase faster and faster as my x values increase. Okay, so increasing at an increasing rate. An increasing rate might be one way to put that. Okay, rate of change, that is here. We're going to study rate of change in chapter 2. Increasing at an increasing rate. So we're increasing faster and faster and faster. That's something that's unique about this graph. Non-constant. This is non-linear here. Okay, S is shape. What have we said about shape so far? Well, this is an exponential graph. Looks like an exponential graph. It is J-shaped. Okay, we might say it's curved, going up. Okay, interesting thing about it is it was always increasing too. As I put my finger here, it's only going up. It's only going up very slowly at first, but then faster and faster here. So it doesn't decrease at all. So we just have that J shape. Okay, J-shaped here. Okay, and we have here S. What's the next S here? You got to remember M.I.S.S.R. So talked about shape. What do we talk about next here? Is you got to kind of memorize this. Symmetry. Okay, symmetry. Do I have symmetry here? Well, let's see here. If I drew a line of symmetry here, would my left side look exactly like the right side? No, I don't have this. It goes up over here. It's not going up over here. So no, that's not a line of symmetry. What about over here? If I do this, when I fold it? Well, no, this is kind of straight here almost. It's almost straight. It's increasing so slowly. This is going to increase faster and faster. So if I fold it here, they're not on top of one another either. Okay? If I do like this, is that? Well, no, it's going to be over here, maybe a little bit, but I'll miss this part of the graph. Okay, so here, S, that's symmetry. Okay, so look here, I had minimum points, I had increasing, I had shape was J, I had S, this is symmetry. So here, S, I would say no symmetry. Allergies acting up or something. No symmetry. And then I've knocked that one off. Okay? 2 left. I can look up. I can use my notes to figure out what else I need to talk about. Special points. Okay, special points. X-intercept, Y-intercept, vertex. Well, there is no highest point here. Hey, this data just cut off here. So really, this graph would just keep on going, right? It got a lot worse. COVID got a lot worse in 2020. Okay, so it kept going as exponential for a while. And then again, it sort of leveled off afterwards. It wasn't always exponential. But anyways, here, key points, well, it looks like I just have my y-intercept there. Okay, so I don't have a vertex. I don't have one highest point really. So I can't talk about my vertex here. So my special point might be talking about, well, when did the data begin? Well, we begin with 20 deaths. Well, that's significant because everything else was higher than that. Okay, so special points, I have an x-intercept. Oh, sorry, not x-intercept, it's y-intercept. Okay, so if you're having trouble looking at your graph earlier, okay, this here is my x-axis. There it is right here. Nope, a little bit too high. Where it says when y is 0, that's where my x-axis is going to be. Okay, x values of when y is 0 would be on my x-axis. Okay, so there's my x-axis. Here's my y-axis here. So this is an L-shaped graph. You don't have the whole thing. You don't have all 4 quadrants. If you studied quadrants at all in the past here, there's my y-axis here. Okay, so here, this graph, this yellow graph here, intersects my y-axis at about 20 or so, just a little bit above that origin here. Okay, so special points here, special point. I just have one special point here. I don't have an x-axis, interestingly enough. A lot of exponential functions won't have x-axes. X-intercepts here. I have a y-intercept, okay, because I have my y value here is 20, when my x value is 0. Okay, so special point is my y-intercept at 0, 20. Okay, and then finally, R, restrictions. Okay, what about this? What can I say about x? So x and y here. What are all my x values? Well, my x values are all positive. Okay, all positive. Why? Well, COVID started at some point. We were starting with our data at some point here. So my x values are all positive. Kept going, probably kept going forever. So x values are all positive numbers. Okay, what about my y values? Well, this is about deaths, right? Okay, it's about death. Can you have negative deaths? So no, I don't have it in my graph down here when y would be negative. I don't have that near us down here. It'd be negative down here. So it's all above the x-axis here. So x values are all positive numbers, and y values got to be all positive numbers based on just logic, right? There's a graph about COVID deaths. So deaths can, they could be 0 if nobody died, but it can't be negative. You can't have -5 deaths someday. I wish we could bring people back from the dead. Well, some people at least. And some people might not want to because it'd be all gross. Anyway, ending on a weird note here. I'm talking to nobody. I'm talking to myself, so that kind of happens. All right, message me if you have any questions. M.I.S.S.R, minimum or maximum points, increasing or decreasing, shape, symmetry, special points, and restrictions. And describe them all, and we'll work with the stuff all year, describing different things here. Message me if you have any questions. Thanks. Bye.